Hello. 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 So, good evening. This is the continuation of day 4. Today we going to discuss outlier test based on our student. Okay. So, an outlier test based on our student a common way to model an outlier is a mean shift outlier model. So here we consider mean shift outlier model. Hello, Subrojit. Good evening. So, suppose with observation the outlier. So first I write the model. This is the model. Y in beta plus epsilon, and at with observations the true model is Y in beta plus delta epsilon, where this is the vector this is the ith observation. Suppose I have a p explanatory variables or k explanatory variables, then we write this model as and we assume that outlier occur at with observations, that then del u equal to yu equal to I think it is I1. So should be writing u1 beta 1, u2 beta 2, uk beta k plus delta. This is because for outlier plus epsilon u. So in matrix notation, we write the true model as this. This should be curl curve, then where del curl equal to prime. This is the uth position, occurring uth position. So I think it's better to write del suffix u. Okay, del suffix u. So where epsilon curve follow in dimensional normal, suppose we have a in observations 0 curve sigma square I is the identity matrix of order n. For both the models we fit. And objective is find an appropriate statistics for testing H naught del u equal to 0 versus alternative hypothesis del u not equal to 0. And this means we are interested in deviate observations only. That is because we have a priori information that eth observation may be an outlier. Okay. So step 1, first we estimate del u because this is unknown. This del u is unknown. So we need to estimate it. And this is the error term E curve, and this is nothing but a I minus H. We know already this thing, Y curve, which gives E curve, and where H is projection matrix or hat matrix, then we see that expectation E curve 0 curve and sorry, expectation E curve is, since this is not a zero curve here, because I minus h expectation y curve for true model should be x beta curve plus del curve and x minus h x beta curve plus del curve minus h del curve, and this is zero curve. So this equal to del curve minus h del curve. This is nothing but I write that I minus x x prime x whole inverse x prime del curve. So there we see that expectation ei expectation ei equal to 0, and where I not equal to u, and for I equal to u, then it should be 1 minus h u del u, where h u with diagonal element of h. Okay, so we get expectation eu is 1 minus h u del. Here h u is known, so del u hat is eu hat by not eu hat, sorry, this is 1 eu by 1 minus h u, and we see that del u hat is an unbiased estimator of del u. It may be observed that del u hat is simply the with press residual and further dispersion of the curve, which is equal to dispersion of E curl means this I minus h y curl, and this is equal to sigma square I minus h, because I minus h is idempotent matrix. And this implies variance of EU is sigma square 1 minus HU, and hence variance of del U hat, which is equal to 1 minus HU whole square, variance of EU, nothing but a sigma square 1 minus HU. And also we see that E curl, E is a linear combination U is a linear combination of Y curl, because this is the reason. If you see the component of E curl, then you see that E curl is a linear combination of Y curl. So from the property of normal distribution, since YIs are independent, so EU follow normal distribution, which mean del U, sorry, which mean 1 minus HAU del U and sigma square 1 minus HU, and thus del U had follow normal distribution, which mean del U and variance sigma square 1 minus HA. So since here sigma square is unknown, so we estimate sigma hat square by ms due to error. Therefore, test statistics is T, which is equal to LU hat by root over ms error by 1 minus h u, and this follows T distribution with error degrees of freedom, that is n minus k minus 1. and uh, this is your homework. Because t distribution, we have to show that E is 1 minus hy and SS due to residual or error, that is y curl prime I minus h y curl, these are independent. You have to show this thing. So you should check this thing. This is your homework, and this is happened. So that is for this reason we say this follow the statistics T follow T distribution with error degrees of freedom. Okay, so sorry, actually I want to mean that if this thing is happened, if these are independent, then this follows T distribution n minus k minus 1 degrees of freedom. Otherwise we cannot write. So okay, first we need to check this thing whether this is independent or not. So see that, so covariance E curve and SS due to residual. So this is nothing but a this is, this is a well-known multivariate result, sigma square I minus h. Okay, so then this is nothing but a sigma square I minus h, and we see that this is not equal to 0, hence E curve and SS due to residual are not actually independent. So hence this portion is not true. That is, this is not follow T distribution with n minus 1 degrees of freedom. Okay. So for this we recall, which I already developed, SI square, which is equal to, yes, Shubhajit, MSC is calculated including in the UAT observation, or yes, included in the UAT observation, not excluding UAT observation. If we exclude this, then this is independent, because we do not exclude, that's why this is not independent. Okay, Shubhajit, MSC obviously, otherwise we use the notation this. Shubhajit, please tell me, are you happy with my explanation? Okay. So we know we already knew this result, n minus k ms due to residual or error minus ei square 1 minus hii. Now we exclude ith observations and define this thing. We already knew this thing in our previous class, from our previous class. We developed this thing already. So we use this fact. So this estimate we already, if you use this estimate of sigma square, and then then EU and SU square are independent each other. Okay, so then the appropriate test statistics equal to AU SU root over 1 minus H U. Okay, and this is follow non-central T distribution with degrees of freedom n minus k minus 1, and let lambda is a non-centric parameter. And where is lambda equal to you can check this thing del u by sigma root over 1 minus HAU, which is del u root over 1 HAU sigma, and under H naught, this is this, please check, this is your homework. Okay, so under H naught this should be 0, hence under H naught this test statistics T, I think it is better to write T star because we already used T for this. Okay, so under H naught T star follow T distribution. This is central T distribution with n minus k minus 1 degrees of freedom. Okay, and note that the power of this test depends on HU if we fit an intercept to our model. Then the diagonal element of head matrix lies between this. So please check, this is your homework. The diagonal element of head matrix lies between 1 by n comma 1. So maximum power occurs when HU equal to 1 by n, because if you look at the expression of non-centric parameter, then you see that lambda increases when HU decreases. That is, at the center of the data, data cloud is terms of the excess as HU tending to 1, the power goes to 0. In other words, the test has less ability to detect outliers at the high leverage data point. And we will discuss later the leverage concept of leverage point. Okay. So have you any question up to that? Please tell me before going to the next portion, that is the test for lack of fit. If you have any question, please tell me. Subhojit, have you any queries? So I observe that there are 8 of you watching this video. One is Subhojit. Please tell me other 7. Chandrima, okay. So Subhojit and Chandrima. Then what about the remaining 6? Holika, okay. Remaining 5. So next topic is test for lack of fit of regression model. So suppose the assumptions of normality holds. Assumption of normality hold. Also assumptions of independence holds. And assumptions of constant variance. This is also oil. Okay. So these assumptions suppose hold. Okay. Then and you fit, and our doubt is we fit a linear regression, and doubt is this relationship is appropriate or not. So for example, suppose if you look at the scatter plot, like this, and from this scatter plot you can see that the straight line fitting is not satisfactory. That is, straight line fit so we need a test to determine if there is systematic curvature is present. That means the test procedure determines if there is systematic curvature is present. For this test, or I think I write in that way, the test required replication requires replication of observation, that is observation on Y for at least one level of one level of X, and they should be two replication. So I mean to say, for given X, suppose X1, you need to take more than one observations. That means given a label of x, that is for x1, you need n1 observations. That means for x1 there are n1 replication. That is the repeated measurement of anything. Suppose measurement or observation, etc. So for x2, suppose we have this. For kth observation should be okay. So, and they should at least one level of x, and they should replicate, they should be true replication. They should be true replication, and not just the duplicate reading or measurement of y. Suppose the true replication consists of running ni separate that means true replication consists of running ni separate experiments at x is equal to xi. That means suppose for this, suppose you have you ask n1 people to take measurement of same instrument. Okay, so that's why the true replication means this is consisting of ni separate experiments at x is equal to xi, and measuring y ni times, in which the information only on the variability of the method of measuring y is obtained. These replicated observations are used to obtain a model independent estimate of sigma square. Suppose I already mentioned that, suppose we have ni observations on y, at the ith level of xi, where I from 1 to m, let yij be the jth observation on y at xi, where I from 1 to n, and n is a total number of observations, so it should be I from 1 to k in I into total number of observations. So please wait. Okay. So okay. So suppose we have ni observation on y at the ith level of xi, let yij be the jth observation of y on y at xi. So the model is yij beta naught beta 1 xi plus here, and then the ijth ijth residual that is yij minus yi bar, where yi bar, this is equal to 1 by nj sum over j from 1 by ni sum over j from 1 to ni yij. So this we can write this as yij minus, sorry, I think this is my mistake, sorry. So this is the model, okay, not yij, this is the model, and this is the model, okay, and then the residual is yij, because ij residual is yij and minus yi hat, which is the fitted value, okay. So see that why it is, see that xi y1 I1, yi2, yi and the corresponding fitted value is yi hat. So for this reason the ijth residual is yij minus yi hat, and we can write this as yij minus yi bar, which is array mean or mean of this we already defined, plus yi bar minus yi hat. Okay, so now sum over I from 1 to k, suppose we have, okay, sorry, here I denote xi from 1 to m, not k. Okay, so please change, if I write k, should be m. So yij minus yi hat whole square sum over j from 1 to ni, this is equal to sum over I from 1 to m, j from 1 to ni, yij minus yi bar whole square plus I from 1 to m ni yi bar minus yi hat whole square, and you can check that the cross product term is vanished. Okay, so now if I write k, please change k by m. Okay, so this is sum of square due to residual, this is due to residual, and this is SS due to pure error, that is sum of square due to pure error, and this is SS due to lack of fit. Hence, this measures lack of fit, and this measures pure error. So, if assumptions of constant variance is satisfied, then SS due to pure error is a model independent measure of pure error because only the variability of y's at each x level is used to compute SS pure error. Since there are ni minus 1 degrees of freedom for pure error at each level of xi, the number of degrees of freedom associated with SS due to pure error is because of the property of, because using the Cochrane's theorem, this should be sum over I from 1 to n ni minus 1, which is equal to n minus n. So SS due to lack of fit is a weighted sum of square deviation between yi bar at each level of x and corresponding fitted value if yi hat are close to yi bar, then there is a strong indication that the regression function is linear. Okay. If yi hat deviate greatly from yi bar, then it is likely thus regression function is not linear. The degrees of freedom associated with S's due to lack of fit is m minus 2, because there are m levels of x and 2 degrees of freedom are lost due to two parameters. One is intercept, another is slope. So because why? Because two parameters must be estimated to obtain yi bar. Okay. So SS due to lack of fit is equal to SS due to residual minus SS due to pure error. We already see this thing. Therefore, the test statistics equal to F naught SS due to lack of fit by corresponding degrees of freedom, that is m minus 2, and SS due to pure error, this is divided by n minus m. So this is equal to m is due to lack of fit, m is due to pure error, and we see that expectation of m is due to lack of fit, which is equal to sigma square plus I from 1 to m ni expectation yi minus beta naught beta 1 xi whole square by m minus 2. Please check this thing. This is your homework. And if true regression is linear, that is expectation yi equal to beta naught equal to please wait, that is expectation yi equal to beta naught plus beta 1 xi, and expectation m is due to lack of fit, which is equal to sigma square, because you see that this term should be 0, hence this term should be 0, hence the expectation of m is due to lack of fit should be sigma square. And if true regression is nonlinear, then expectation of yi which is not equal to beta naught plus beta 1 xi, and expectation ms due to lack of fit, which should be greater than sigma square. So hence if true regression function is linear, that is under H naught, then the phase statistics F naught is follow F distribution with m minus 2 n minus k degrees of freedom, n minus m degrees of freedom. Okay, so to test for lack of fit, compute F naught and conclude that regression function is not linear if not greater than f alpha m minus 2 n minus m at level alpha, where alpha is the level of significance. And otherwise, we conclude that is if otherwise we conclude that regression function is linear. So if H naught is rejected, that is fitting is linear function, regression function is not linear, then we conclude that if we conclude that regression function is not linear, then the tentative model must be abandoned and we attempt to find a more appropriate model. And if this f naught less than f alpha m minus 2 n minus m, then there is no strong evidence of lack of fit. Then MS due to pure error and MS due to lack of fit are often combined to estimate sigma square. Note that if F ratio for lack of fit is not significant, and H naught beta 1 equal to 0 is rejected, then this does not guarantee that model will be satisfactory for prediction. It is suggested that the F ratio must be at least 4 or 5 times the F alpha m minus 2 n minus m if the regression model is to be useful for prediction. Second note, a simple measure of potential prediction performance is found by comparing the range of fitted value that is y hat max minus y hat min to their average standard error regardless of the term of the model, the average variance of the fitted value is, I denote this by V bar equal to 1 by n sum over I from 1 to n variance of yi hat. which is simply is equal to k sigma square. If you use k explanatory variable, in that case k sigma square by n. So where k is a number of parameters of the model. In the model or explanatory variable. K minus 1 is the explanatory variable. Because if you consider intercept term, then you have k minus 1 explanatory variables. In general, the model is not likely to be satisfactory predictor unless the range of yi hat is large relative to estimated standard error root over k sigma hat square by n, because k and n both are known, where sigma hat square is a model independent estimate of error variance. So estimation of pure error. Now next part is estimation of pure error from from near neighbor. Okay. So in Shubhrajit, sir, if the F ratio is 4 or 5, then the equation is not linear, right? Yes, yes, Shubhrajit. Actually, I write this thing. Wait. Actually, I mentioned this thing. Okay, you asked me that. Actually, I mentioned this thing. This is a thumb rule. Okay, Shubhrajit, this is thumb rule. Because if this thing is 4 or 5 times of this means it's huge. If you compute the p value taking this, then you see that this p value is very small. Okay, so that is the reason the this is we use this thumb rule. Okay, so this is nothing but a thumb rule. If you use this thing and compute the p value, then you see that this p value is very small. Can I continue, Subhajit? Please tell me, can I continue? Or have you any more question? Okay. So, okay. So, estimation of peer error from near neighbors. Test of lack of fit. This is due to residual equal to this is due to pure error plus this is due to lack of fit, where this is due to pure error is computed using responses at repeat observation at repeated observation at some level of x. This is model independent estimate of sigma square. This is the general principle, can be applied to any regression model, and calculation of S is due to pure error requires repeat observations on the response y at the same set of labels on the explanatory variables x1, x2, xk, and in practice repeat observation do not offend. Subhrajit, I moved some second. Okay, Subhrajit. Okay. Oh, Subhrajit, actually 4-5 times alpha level, then the model is appropriate for prediction, but it is contradictory. Okay, so Subhrajit, I am saying that more the ratio actually become 4 or 5 times the f value alpha, critical value of alpha. This means your maximum tolerance is 4 or 5 times f level, But if it is more than 4 or 5 times F value, then this is not appropriate for appropriate. Okay. Please write the please read the note carefully. Okay. Please read this note. I'm waiting. Please read this note carefully. Your maximum tolerance is this. Shubhrajit, I think you should. I think you. It is my mistake. It is better you should change this thing. It is suggested that F ratio must be at least 4 or 5 times the critical value. At least this critical value. If the regression model is not useful, okay, you are right. Okay, but this is my mistake. Not useful. Okay. Otherwise, you can use it. Your maximum tolerance is this. Am I right? Please rectify this thing. This is my mistake. Sorry. So please rectify this thing. If F ratio F ratio 4 or 5 times the critical value, then my default is greater than critical value, and in 10 case we have already lack of fit. Yes, you are right. You are right. So maximum tolerance is 4 to 5 times a critical value. Not okay, because your regression coefficient is significant. Okay, thank you, Subhrajit. Thank you for you rightly pointed out this thing. So this, so please rectify this thing. Okay, thank you, Subhrajit. So calculation of SSD to pure. Can I continue, Subhrajit? Please tell me. Can I continue? Subhrajit, please tell me. Can I continue? We have you. Subhrajit, can I continue? Yes, sir. Okay. Thank you. So require repeat observation on the response y at the same set of labels on the explanatory variables x1, x2, xk. In practice, the repeat observation do not often occur in multiple regression, and the procedure of lack of fit is not often useful. The method to obtain a model independent estimate of error when there are no exact repeat points are produces which search for those points is X space, those point in X space that are near neighbors. This is the set of observation that have been taken with near identical levels of x1, x2, xk. The response yi from such near neighbors can be considered as repeat points and used to obtain an estimate of error. As a measure, the measure of the distance between any 2 points x1, x2, xk and xi dash 1, xi I think any 2 points means I think it is right that way. Any 2 point xi1, xi2, xik and xi dash 1, xi dash 2, xi dash k use weighted sum of squares sum of squares, square distance, sum of square distance, WSSD, where DII dash whole square defined as sum of j from 1 to k beta j hat xi j minus xi dash j whole square by root over ms due to residual. So this should be here. Okay. And the points the pairs of points with small values of DII squares are near neighbor, that is, they are relatively close together in X space. Pairs of points for which DII square is large, that is, DII square very larger than 1, are widely separated in X space. The residuals are 2 points with a small value of DII square can be used to obtain an estimate of error. The estimate is obtained from the range of residuals at points I and I dash, say EI equal to absolute difference between EI minus EI dash. There is a relationship between the range of a sample from a normal population from normal population, and the population standard deviation. For example, when the sample size equal to 2, then the relationship sigma square E by equivalently E by 1.128, which is 0.886 E. The quantity this is for sample size 2. Okay, so the quantity sigma square is obtained is an estimate of standard deviation of pure error. An efficient algorithm may be used to compute this estimate as follows. Step 1, first arrange the data points xi1, xi2, xik in order of increasing yi hat. Next step, note that points with different value of yi hat cannot be. Okay, Shubhaj, how does this become an estimate? I am missing something definitely. Actually, Shubhajit, I cannot understand which one. What is your question? Actually, I also miss which one. How does this become an estimate? I am missing something definitely. Which one, dear? Please tell me. So I think this portion, okay. EI, E. We defined as a absolute difference between EI minus EI dash, EI dash. Okay, see that. And if you ask this is for example, okay. This is the relationship between, one thing. This is approximately standard deviation range as relationship between standard deviation and range. I think this should be approximately R by 4. This is one of the thumb rule. This is that also. Okay. So how does I become the estimate of period? It cannot be, okay, this is empirical. Okay, this is okay. Yes, this is empirical. Pure error cannot be estimated. Pure error cannot be estimated. What do you mean? How does AI become a pure error? Pure error cannot be estimated. Why? Actually, standard deviation of pure error, not pure error. This is the estimate of standard deviation of the pure error. Standard deviation of the pure error, not pure error. The estimate of pure error is not correct. This is the estimate of standard deviation of pure error. See this line? Vijay? Vijay, are you hearing me? This is the estimate of standard error of the pure error. Subhajit, are you hearing me? I am waiting. Okay. To become an estimate of something, there has been something rational. Subhajit, please write more. Okay, I can understand what is your queries. At least I can understand. Sir, I am typing. Okay, okay, you take your time. I am waiting for it. Subhajit, the one thing I am telling, do you know the pure error? If not, then you need to estimate. So, please tell me. Okay. EI and EI dash are the residuals, and the difference between them are estimating the pure error, including by the observation. Did I make it right? Yes, you are right. You see that? You are absolutely right. This thing. This is the mathematical expression. Okay, yi equal to mu I. Error included by the ith observation, didn't right? Yes. Then yi equal to mu I plus ci. Okay. No, actually, for estimating pure error, you need a replication of y, of replication of ith level of x. I will be. This is required. EI is a pure error. Yes, EI is a pure error. Then my question is how mod value of difference between two residual estimate that error. Actually, the residuals are too small value of where I used to obtain the estimated period, estimate of the obtained from the range of residual. Okay, so actually this is the range. Okay, the range means absolute value. So range is a absolute value between. I do not know whether UI is according to you. Okay, could be some estimate of something. There may be some mathematical derivation or at least some. Uh, no, actually, sense is that one thing you can you forget about the sign. Okay, actually your problem is the sign. Okay, I don't know, these two are dummy variable. Okay, I and I dash. So uh, and you consider just the absolute value of the error, not the sign. Okay, if you ignore the sign, I think then you have no problem. Actually, this gives the estimate of the magnitude of the error. Actually, we ignored the sign. Am I clear? Am I right? Subrojit, can you satisfied with my argument? Actually, we estimate the magnitude of the errors, not uh, the sign. Actually, here the sign does not make sense because I do not know uh, whether EI is greater than EI dash or not. Subrojit, please tell me. EI is the estimate of pure error EI. Yes, EI. See, pure errors, you just ignore the sign. Why? Because I and I dash, you don't actually, we are interested in the magnitude of the error, not the sign of the error. Okay. Subrojit. So if you have a problem, you can ignore this thing. Sample mean is the estimate of the population. Okay, okay, Shubhajit. I know. If you have a problem, then you can ignore all this line. Just you write EI, because we are interested only in the estimate of the standard error or pure error. Okay. So if I write this thing EI minus EI dash, I think you have no problem. But think that EI and EI dash, EI minus EI dash, is it nothing but either the range or minus of the range? So for the symmetry, we write this thing. If you have a problem, you can write this thing. If you take this value, you have no problem. I have no problem. If I write EI minus EI dash, is it okay for you or not? Tell me, Shukrojit. One thing, unbiasedness is a okay. If you change the divisor of the sample mean from m to n minus one, this is not unbiased anymore. But still, Subrojita, one thing I am telling you. Yes, you are right. You are absolutely right. Unbiasedness is the property of the estimate. So, uh, if you search for a is estimate or estimator of some parameter, it can give any functional form. Not intuition. Uh, this is not an intuition, okay? Pure error, this EI is not a pure error. And EI dash is, see, there is some common portion. EI pure error, it has a pure error plus common thing. Pure error due to ith observation, common. And EI dash has a pure error for pure error for ith observation, pure error for is there any reason I dasheth observation, pure error for I dasheth observation plus common thing. So if you subtract these two, then you get a pure error, estimate of the pure error. See that the relationship. So actually, where I write this thing, I used to obtain the estimate of pure error and estimate obtained from the range of the residual of the point. There is the ratio. So if you subtract these two things, this gives the pure error. So you can consider pure error is a absolute value. Okay, absolute value. Absolute the pure error of ith observation is the absolute value of something. So if you subtract these two, yes, Soin Chopra, you can, Aryan Chopra, you ask. Have you any doubt that you should ask? I'm you Subhrojit, see that the pure error is not the error. Suppose we have a nearly symmetric distribution in the case, it is likely that the median will be close to mean. In that case, we may use same median to estimate the population mean probably. Okay, so yes, you are right. Then what is your question? So in that case, we have a reason to believe that the sample median can be estimate of the population. Yes, you can population mean, or you can think about the location parameter. So sample median is also estimate of the location parameter. So you can also use sam mode, okay, sam or you can use single observations or anything. Actually, you give a estimate who such that which cover the range of parametric space. Okay. Aryan Chopra, you can ask. I am waiting for your question. So, you think about that. So then, Subhrojit, please. I'm. So, what is your question? So, can you choose any arbitrary functional of a random sample to estimate? Yes, Subhrojit. One thing. See, suppose simple example. Suppose you consider normal population mu sigma square, where sigma square is known. Okay. So your mu lies between minus infinity to plus infinity. For this, you draw in observations, for example, and so for estimating mu, you can use x1, x1 plus x2 by 2, or x1 plus x2. You have a no problem. X curl, median, x bar, etc. So many, but you should choose those such that the range of the estimator should be minus infinity to plus infinity. You should mind this thing. The range should be minus infinity to plus infinity. Okay. So Shuprajit, I think I guess your queries. So that's why you're telling the pure error should be lies between minus infinity to plus infinity. So sir, why you select the absolute value, because absolute value should be lies between 0 to infinity. Am I right? Am I right, Subhrajit? Subhrajit, am I right? If I am right, I'm telling you here error consider only absolute value. Pure error is absolute value. Okay. Okay. EI is not a pure error. EI is not a pure error. Are you okay with that or not? Is it EI is a pure error? My answer is no. EI is not a pure error. No, you cannot estimate this. I already mentioned this thing. For estimating pure error, I need more observation for a particular level of xi. Okay. Otherwise, we cannot get the pure error. Why? I am telling you. For simple things, you have a something. You if you measure this thing, you have a error. But your friend measured this thing, he or she has a error, but this error and this error are not same. Okay, so for estimating these two, the pure error, just subtract these two things. Yes, CI is not a pure error. Shubhajit, I think we will discuss this issue later. Okay, for time being, we can happy with this. I think we will discuss later because the people, those who watching this, I think they can understand. I think you and me have some problem. So I think let this matter for time being. Let this matter drop for time being. We will discuss this issue later. Okay. So please excuse me, dear. So I think I will continue this thing. You take your time to think about pure error. What do you mean by what is the difference between error and pure error? So then we will discuss. Okay. So we back to the this thing. The note that. Thank you, Shubhrojit. So note that the points with different value of yi hat cannot be near neighbor, but those with similar values of yi hat would be neighbors, or they would be near the same contour of constant y hat, but for apart in some x coordinate. Then compute dii square for all n minus 1 pairs with adjacent value of y hat, and repeat this calculation for the pairs of points separated by one, two, or three intermediate y hat values, and this will produce it. So this will produce four n minus 10 values of dii square. Next, arrange the 4n minus 10 values of dii square found in step 1. Let u from 1 to 4n minus 10 be the range of the residual at these points. Then for the first m values of u, calculate an estimate of standard deviation of pure error is sigma hat 0.886 by m u from 1 to m eu. Note that sigma hat is based on the average range of the residual associated with m smallest values of du square m must be chosen After inspecting the values of u squared, one should not include values of u is the calculation for which the weighted sum of square distance is too large. So I need to stop here. So have you any queries? Please tell me. Subhrajit, please write your query to me personally. I will definitely address you either over the phone or message. Okay. So, and Aryan Chopra, you tell me you have a doubt. I have not get from you anything about your queries. Okay. So if you have any queries, please write. I will address your query and tell me if you have anybody having any problem regarding the today discussion. So please tell me. Otherwise, I want to end the stream. And we will again join coming Thursday at 6 p.m. same time with the transformation. The topic, the transformation. We'll discuss the transformation. Hoop distance. It's a hoop distance. Okay. So till then, thank you. So please tell me, have you any doubt? Subhajit, okay. And one thing I am telling you, I am very much happy with you. Only you ask lot of questions and I am enjoying you. Enjoying you with your question. Okay. So please do not stop to ask me. Always, if you have any queries, please tell me anytime, any moment you can ask me and I am always with you. Thank you, dear. So thank you, everybody. So we will meet again on Thursday, 6 p.m. same time with new topic, that is transformation and